Our ancestors could only imagine how the solar system's planets looked up close. Then along came telescopes, and we were able to see them a little closer from Earth. But as technology evolved, we were able to create probes and send them off to get a closer look at the gas giants, the rocky worlds, and even as close as we can get to the Sun without one burning up. For the first time in human history, we can now observe images of the celestial bodies in our solar system with a level of detail that was once only possible through fiction movies. Get ready to see sunlight glinting off the lakes of the solar system moons, the clearest views of Jupiter that unraveled its fascinating mysteries, and the microscopic details of the Sun's structures as we get closer than ever to the amazing and mysterious worlds and see them like you've never seen them before. In 1979, the Voyager 1 and Voyager 2 probes both made close flybys of Jupiter. Together, the probes grabbed over 33,000 breathtaking images of the celestial giant and its moons. When Voyager 1 got close to the gas giant, it gave us a much better image of the Great Red Spot, this once mysterious and distant storm about the size of planet Earth was finally revealed in such high detail that it stunned astronomers. And then, in 2016, the Juno spacecraft entered the gas giant's orbit and became the very first probe that was able to peek below the planet's dense clouds. The quality of the images the spacecraft sent back dwarfed all previous observations. Jupiter's clouds are extremely thick, but Juno's microwave frequencies allowed the spacecraft's instruments to measure water deep into Jupiter's atmosphere. In this image, on the left, the gas giant's clouds appear somewhat like the human eye would see them. And on the right, the colors and contrast have been increased to reveal small-scale features. Just imagine someday being able to see it with your own eyes and not in a snapshot. In 2017, Juno cruised just about 8,000 miles above Jupiter's south tropical zone. Although the bright clouds in this image might seem small, they're actually 30 miles wide and 30 miles high. They're so large that they cast shadows on the clouds below. Scientists think these clouds contain water and ammonia ice and can cause lightning on the gas giant, like this lightning bolt visible in another Juno snapshot. Gas giants' atmospheres are complex, and one distinct feature that Jupiter and Saturn share is jet streams, which are superfast winds that race along the planet's atmosphere, reaching hundreds of miles per hour or more. This is Jet N3 on Jupiter, captured by Juno during one of its closest approaches. The image is so sharp, it shows features as small as 1.6 miles across. On Earth, lighting is a game changer in photography, and it also changes the way things look in space, just like this sunlit side of Jupiter and its swirling atmosphere. And when scientists tinker with the camera's settings, unleashing the power of infrared imaging, they can unveil previously unseen features on the planet. Throw in some color enhancement tweaks, and suddenly the picture looks way more amazing. The closer Juno orbited Jupiter, the better shots it took, like these images of the planet's gigantic storm. Every 5 weeks, it swings by the polar regions, shooting signals back to Earth. On its 46th go-around, Juno's camera took a magnificent picture of Jupiter's northern cyclones, massive storms that have been swirling around for more than 5 years. And by the way, the spacecraft is still orbiting Jupiter and will continue to do so till 2025. Meanwhile, the James Webb Space Telescope saw the gas giant in a completely new light, providing us with the latest images of Jupiter up to date. Jupiter's moons have had their close-up moments too. And although they haven't grabbed the spotlight as much, some of the images we've got are right up there with the best shots of the Earth's moon. This is the surface of the largest of Jupiter's moon, Ganymede, as it was seen by Voyager 1. Ganymede is the biggest moon in the solar system, even larger than the planet Mercury, and has two types of terrain. The dark stuff is ancient, while the lighter bands are much younger. But even that isn't the most detailed image of the moon's terrain. Here, what looks like a piece of metal under a microscope is actually a close-up shot of grooves and ridges on Ganymede's icy crust. And this is another of the gas giant's many moons, Callisto, with an intricate circular structure that astronomers think is the sign of the satellite's low density. On the surface, it looks similar to the Earth's moon, all rugged and scattered with small impact craters. This tiny sphere of rock with the mighty Jupiter in the background is Io, captured in 2001 by NASA's Cassini spacecraft. And although the two celestial bodies appear to be close to each other, there's 2.5 Jupiters worth of distance separating them. And that's how the moon looks up close. Scientists believe it has 400 active volcanoes. One of them is named Rapatira, which is currently spewing rivers of lava that flows down its flanks. The moon also has towering mountains higher than those we have on our planet. Probably the most famous of Jupiter's moons, Europa, was orbited by Juno within just 220 miles. Europa has a fractured surface with small rounded domes, bands and ridges, but it's also covered with broken ice, which scientists think hints at the existence of a liquid water ocean underneath the moon's surface. Perhaps one day in the future, we'll have technology so advanced it will allow us to detect the presence of subsurface oceans on extraterrestrial celestial bodies with a 100% certainty. But meanwhile, let's continue our cosmic voyage and take a closer look at another impressive gas giant that is a big favorite of stargazers and astronomers alike. "400 million miles away from Jupiter sits a mesmerizing gas giant surrounded by iconic rings of dust and debris. And if you think you've seen incredible images of Saturn, then get ready to take a look at the latest images. But first, a little from the beginning of this planet's exploration. Galileo was the first to observe Saturn's rings with his 20-power telescope. However, the early astronomer had no idea he was looking at rings. He instead thought there were two moons in tight orbit, making it look like Saturn had handles on each side. Astronomers of the past were onto something and weren't completely wrong. A new study based on 200 computer simulations suggests a relatively recent collision between two icy moons close to Saturn. Back in the early 1980s, the Voyager spacecraft made its historic encounter with Saturn and gave us a chance to observe its rings from a distance never before achieved. Today, we know that the majestic ring system is not only a razor-thin structure mostly composed of ice particles, but also pieces of comets and asteroids. The material is pristine, and it's only a few million years old, which means that the debris from the collision is still orbiting the planet. In these images, made by the twin probes, you can see bits of the icy shattered moons in a celestial dance around Saturn. But then came Cassini, which offered us even better visuals of the planet, its rings, and showed a whole new group of moons, and a whole new group of previously undiscovered moons. In this shot, the probe captured an enormous-sized storm raging in the planet's northern hemisphere. A little higher, over Saturn's North Pole, Cassini snapped something even more spectacular. A spinning vortex with an eye that's 1,250 miles across. The colors in this image aren't real, but they're like that for a reason. They represent a distinct wavelength of near-infrared light. In a way, a color code is a type of cosmic language, and in this case, red shows low-lying clouds and green depicts the ones that float higher in the atmosphere. Although the image was captured at about Earth to Moon distance, it has a scale of just 1 mile per pixel. Probably the best picture of Saturn up to this date is this stunning panorama. that consists of 165 separate images. The planet's atmosphere has also been closely observed by Cassini. What looks like a watercolor painting here is the view of Saturn's clouds where sunlight is absorbed and scattered by the planet's methane-rich atmosphere. Auroras also bring color to this distant world, but unlike northern lights on Earth, they're invisible on Saturn unless you use a specific camera. Both on Earth and Saturn, auroras happen when charged particles from the Sun hit the planet's atmosphere. On Earth, we see them as colorful bands in the sky, but on the ringed planet, something different happens. The way Saturn's atmosphere interacts with the solar wind makes these lights show up only in the ultraviolet spectrum, the type of light the human eye cannot see. And this angle shows just how thin Saturn's rings actually are. A tiny bright spot on the left is one of the planet's 146 moons, Dione, which isn't as small as it may seem. By comparison, the Earth's moon is just 3 times larger. Saturn's natural satellites are just as majestic. Scientists believe some of them might hide a subsurface ocean and, potentially, alien forms of microbial life. One of these moons is Enceladus, as seen by the Cassini spacecraft. Enceladus is a unique moon teeming with geological activity. As the moon orbits Saturn, it leaves behind a trail of particles erupting from its geysers. Here's a closer shot made by the probe during one of its flybys. And the trail doesn't fade away. Instead, it forms Saturn's E-ring. Astronomers using data from the Cassini spacecraft have created an infrared global map of the satellite. The northern part of Enceladus is covered with craters. This means that the surface over that region is old, as it hasn't been renewed by any geological activities for a very long time. In this detailed image, you can see how the newly formed terrain on the right looks compared to an older cratered area. But the south pole of the satellite is a completely different story. It experiences bursts of ice and vapor that scientists think come from an ocean under the icy surface. There, at the bottom of the ocean, could be hydrothermal vents, generating heat and powering crucial chemical reactions, which can theoretically create a habitable environment of primitive forms of life. We don't know for sure if Enceladus hosts life as we know it, but it's interesting to imagine how it would look like. Saturn's largest moon, Titan, is another promising candidate for the existence of life beyond Earth. During Cassini's exploration of the giant satellite, the probe detected strong evidence of liquid surface lakes, primarily made up of methane and ethane. The dark patches in these images have a shape that suggests they've been carved by liquid. And here's an artist's concept of how they might look on the surface of the satellite. Although the processes behind the formation of lake basins on Titan would be different. Here on our planet, they typically result from glacial, tectonic, or volcanic activities. But on Titan, they emerge from outgassing. During warming events, liquid nitrogen deposits in its crust heat up, transforming into vapors and creating openings or holes in the moon's surface. When flying during daytime here on Earth, we can sometimes see the sun reflecting off lakes and rivers from airplanes. The Cassini spacecraft managed to capture something like that on the Titan moon, although from a much higher altitude, about 18,600 miles. This iconic near-infrared image shows a spectacular reflection of Titan's lake named Kivu Lacus. But Titan doesn't just have lakes. There are also seas on its surface. Despite Titan's frigid conditions compared to Earth, its surface is warmed by a strong greenhouse effect resulting from a high concentration of methane in its atmosphere. Some scientists believe that a hypothetical non-water-based life with molecules that consist of hydrocarbons can exist and thrive in Titan's liquid methane lakes. While Saturn and its moons have been extensively studied, there are celestial bodies in our solar system that remain shrouded in mystery, ready for surprises to be unveiled that could astonish the scientific community. But Saturn is not the only iconic planet in our solar system. There is another just as famous, if not the butt of many bad jokes or puns. On its way out of the solar system, Voyager 2 visited Uranus and saw it as an almost featureless pale green sphere. But Uranus is a lot more than that. The ice giant experiences auroras, has clouds, and even has rings, although they're not as distinct as Saturn's. But a nearly 50-year-old probe still managed to take a few close snapshots. There aren't many great images of Uranus, but the James Webb Space Telescope and other spacecraft alike will soon change that. The JWST has already started exploring this distant world, giving us a chance to see it as it's never been seen before. In this wide view image, the telescope's camera shows Uranus and 6 of its 27 moons. Zoom in, and the planet reveals its radiant rings, glowing clouds, and a polar cap. As we venture deeper into the cosmos, we stumble across yet another captivating world. We know Earth as the blue planet, but the bluest of them all in the solar system is Neptune. In 1989, as Voyager 2 was rapidly approaching the planet, it snapped this image from a distance of 10 million miles away. Just like Jupiter, Neptune has a famous atmospheric feature. It's called the Great Dark Spot, a storm that's wider than the Atlantic Ocean. The planet also has smaller dark spots, which are all vortexes of swirling air and liquid, forming at mid-latitudes, traveling throughout the atmosphere, and sometimes changing their direction. If that sounds chaotic, it is. Neptune's weather is probably the most violent in the entire solar system. It has incredibly strong winds of frozen methane blowing at astonishing speeds of over 1,200 miles per hour. That's 1.5 times faster than the speed of sound, and about 9 times faster than the strongest winds on Earth. And then there's Neptune's largest moon, Triton, subtly present in the cosmic darkness accompanied by its planet. All the other moons in the system are about 200 times smaller in size. Researchers think Triton was once a Kuiper Belt object, which was captured by Neptune's gravity sometime in the distant past. The best image of this mysterious world was taken by Voyager from an altitude of 90,000 miles above the satellite's surface. Even this far away from the Sun, Triton is still geologically active, and its surface is one of the youngest in the entire solar system. So astronomers suggest the Moon could still be warm and possibly have a liquid water ocean. If that turns out to be true, this world would be the most distant celestial body in the solar system that managed to retain water in its liquid form. Just how distant? About 30 times further away from the Sun than Earth. Such a revelation would shatter our assumptions about water worlds and force us to rethink the processes behind the existence of liquid water on celestial bodies separated by billions of miles from the nearest stars. But let's delve into the very heart of our solar system, the Sun. Recently, we've captured some truly astounding images of this natural, massive, celestial nuclear reactor. At the center of our solar system lies this enormous burning sphere with temperatures that soar into millions of degrees. This one major fact has long been a problem for astronomers wanting to get a closer look, but that all changed with the invention of next-generation telescopes and spacecraft. NASA's Parker Solar Probe became the first man-made object to fly through the corona, the outermost layer of the Sun's atmosphere, which is much hotter than its surface, reaching 2 million degrees Fahrenheit. This image was made by the probe from inside the corona as it rushed through this hellish realm. The Sun's outer layers are like a giant pot of boiling water, full of bubbling energy. Huge bubbles of charged plasma move around, creating the Sun's dynamic atmosphere. And sometimes it splashes chunks of plasma into the cosmos. Billions of tons of particles travel through the vastness of space, and if they move in the direction of Earth, they can reach our planet in just a few days. One such outburst of solar material was captured by the Solar Dynamics Laboratory, and recently, the biggest solar flare in years disrupted radio signals here on Earth. The Solar Dynamics Laboratory managed to take an image that shows just how violent the spike in the Sun's activity was. The solar orbiter, that's only been in operation since 2020, brought us an even more vibrant view of the Sun, like this mosaic of 25 images taken in ultraviolet light, and a series of extremely close snapshots. but even that fades into comparison with the 4-meter Earth-based Inouye Solar Telescope. This technological marvel has managed to observe the Sun as if it was under a microscope in one of our laboratories, and the images it can produce are as large as the entire planet Earth. What you can see in this image are huge, cell-like structures, each as big as Texas. They show how heat moves from inside the Sun to its surface, how material rises in bright spots, then cools down and sinks in darker spots. And these are some other strikingly detailed images. They show different features of the solar structure, like sunspots, temporary spots on the Sun's photosphere that are cooler than the surrounding areas and are often much darker. As human technology advances, so does our understanding of our cosmic neighborhood. The images we've learned to take are spectacular, but they aren't just that. They offer a glimpse into what the true nature of these celestial bodies are, and often change our entire perspective. In the coming years, the quality and sharpness of space images will increase to the point where we might no longer distinguish it from computer graphics, and perhaps that's when we'll begin to see the real face of the cosmos. What snapshot did you like the most? Tell us in the comments. We read them all. Stay tuned here for more exciting space discoveries, and thanks for watching.